Hello, the purpose of this video is to demonstrate an implementation of a tuple collection in C++ 17, I guess. I'm probably set up to run here. This is in Visual Studio. A lot of the code came from an article by a Fernando Garcia. The link is here. Okay, so a tuple is a collection of data that can contain different types potentially, as opposed to like a vector which has homogeneous types. There's one type for the whole vector. This tuple code is implemented using variadic templates, which are templates with varying arguments, and recursion. And the first class we will look at here is a template class to hold the value called tuple_val. It has a parameter I and a parameter t. The I is a mysterious parameter because if you look through this template class definition, I is not used anywhere. So what I actually does is it distinguishes a specific tuple_val that's used in a specific tuple. So let's say, for example, I instantiate the tuple with tuple0 int and tuple1 int. Those are different types. Those are not the same type. And that is because even though that I is not, visibly used anywhere besides in the template parameter, it is relevant to the tuple value. The next thing to talk about here is tuple base. And tuple base is going to contain our values, our tuple's element values. So, for example, let's say I say using my tuple equals tuple base 0 int string. Okay, so we're going to have this template, and I is going to be 0. This isn't like a count. This is just we start with 0 and then we go up. I mean, it's not like the count of the number of elements or anything. So I here would be 0. First t would be int, and rest t would be string. Now this could have been more elements. This rest t is a parameter pack and allows for 0 more elements. In our example, we just have one element because first t is int and the rest of the type t is string. So hopefully you can visualize that could be more elements. Then we inherit from tuple_val to hold our value, and we instantiate tuple_val, meaning we create a class tuple_val based on these parameters with 0 and int. And we instantiate tuple base with the parameters I plus 1, which is 1, and rest t, which is just string, because we just have, that one type. It could have been more, like I say, if we'd had more elements in our tuple. And I try to give an example how this sort of expands out. So say we have using my tuple base 0. We just always start with 0 and int and string. So C++ will create, it'll instantiate a class kind of like this, class tuple base 0 int string, and it will inherit from tuple_val instantiated with 0 and int to hold the int, and it'll inherit from tuple base 1 string to hold the string. And then tuple base 1 string will recursively use this template again. Now we'll get something like this. Class tuple base 1 string will inherit from tuple_val 1 string. In other words, we'll instantiate another class tuple_val with I1 and string being the type, and it will also inherit from tuple base 2. We'll instantiate tuple base 2 with the parameter 2. Well, Now when we instantiate with tuple base 2 parameter 2, we will not be able to use this template because this is a specialized template. So we will have to use the general template up here. And that's because the reason the specialized template won't work is because we have I, but we don't have a first t. There is no first t, and that can't be empty. This can be empty because it's a parameter pack allowing for a variable number, but this has to have a parameter. So therefore, we will use our general tuple-based template here, which will just be empty. That stops the recursion and gives us something to specialize from. And so that's kind of how that works. So hopefully it's somewhat clear here how that expands. Next, I'm going to talk about the template constructor, tuple basis constructor. So it's going to be a template member function constructor. And so it needs to initialize its bases. That's what this code does. And here's a template. And our template args are t and rest t. And to some extent, we're going to have to use type deduction here. And I'll explain that. So our type deduction is when we call a constructor. Let's just use this as an example. Tuple base 0 int string. We are passing the constructor 1 and s. So we're passing in an int and a string. Okay, so here on this line here, t is deduced to be int. Rest t is deduced to be string. It's a list, potentially a list of types, but we only have one type left, as there's only two types in the tuple. And these ampersands are our value reference. You can go study up on those C++ 11 move semantics, R value references, universal references, perfect forwarding. That's the kind of stuff you'd probably want to read up on a bit here. And it's just used for efficient sort of copying versus moving of data. And I'm not going to go into that any further. Okay, so the example here is tuple base 0 int string 1 and s. So how does that sort of pan out? I mean, what does C++ do with that? It's going to create kind of a constructor that's going to look kind of like this. This is just an approximation, but tuple base int our value reference first arg, that matches up here with t ampersand first arg. T is int, ampersand is just itself, and first arg is just first arg. That's our argument. So see, there's the first argument to tuple base. So imagine C++ is creating a function with this signature. And then the next parameter is going to be string ampersand arg2. This is a little harder to kind of look at. You see this thing, it's a template parameter expansion. And it's a little confusing because the dots are in front like you'd see up here, like here rest t. And if you notice these expansions, like tuple base rest t that's the parameter pack expansion. It follows the rest t. Well, this is a little different because it's kind of a pattern. And the indicates there's going to be an expansion. Well, what's the expansion look like? Well, we've told it there's a list of types and a list of argument names. Well, the argument names are sort of, I don't know, C++ just kind of creates them out of thin air because we haven't told it what they're called. And the list of types is, in this case, just string. So we would expect something like this, string ampersand arg2. Let's say there was a third argument. We might have a double ampersand arg3. Again, the arg3 is just completely arbitrary. And for purposes of demonstrating what this code is. Okay, so this tuple-based constructor that's created with these two arguments, int and string references, needs to initialize its base. If you look up here, it's got two base classes, tuple val and tuple base. And we went over that when I talked about tuple base. So we need to initialize those members. those base classes, I should say. And this is sort of what will happen. So this is an example of how it kind of would expand the first, the initialization of the tuple val base class. Tuple val 0 int, and then we pass in as a parameter standard forward int first start. So why? Well, here we basically define that we are going to initialize our base tuple val I first t. I is 0, so tuple val 0. First t is int. That was that deduced integer. So that matches up here with tuple val 0 int. And then we have to pass a parameter in. And the parameter, we say standard forward t first start. Well, t is int, so we get standard forward int and first start. And the standard forward, again, is C++ move semantics. You know, if we didn't have standard forward, it would just be first arg and first arg. It would just be, you know, first arg. So if I just put this here and that there, then in our example, that standard forward would be deleted and it would just be first arg. So hopefully that's maybe just deleting it temporarily makes that simpler to understand. Then we need to initialize tuple base. The tuple base, again, we duplicate that from above. We say this is our base. We need to initialize tuple base I plus 1 rest t. There it is. It's kind of like its name, right? Tuple base I plus 1 rest t. In this case, it will be tuple base 1 string, because rest t is string. We peeled off the int. What's left? String. And that's it. And then we have standard forward string arg2, similar to arg1. It's just a little bit different here. This expansion here is a little different because, well, it's an expansion. The other one really wasn't. The other one was just standard forward t. Now we have a list of types. Well, what does it mean when we have a list of types inside standard forward? Well, we've basically put ... here indicating this is an expansion. C++ cleverly says, oh, what you really want here is something like standard forward string arg2. If we had more parameters, more tuple element, types, we'd maybe have standard forward, double arg3. We just keep expanding that out. And yeah, those I find the patterns, a little bit tricky to sort of work with here. Sorry, just redo that edit. Okay. So that's what's being done here. We are just initializing the bases of tuple val and tuple base, and tuple base being recursive. Let's talk about tuple itself. So we have this user-friendly tuple class, which simply inherits from public tuple base 0. So I mean, we could directly use tuple base. We wouldn't ever have to use tuple. Tuple is just user-friendly because it basically says, well, okay, let's go ahead and pass the 0 in, and now the user doesn't have to pass 0 in. So the user can do something like instantiate tuple base with 0 in it, and then basically instantiate tuple with int, and that will inherit from tuple base instantiated with 0 in it, and that's it. Otherwise, it's exactly like tuple base. Next, we'll talk about this get tuple type struct, which will be used by our get function. Our get function actually goes out and gets the values, the elements of the tuple. It gets our int value and our string value. Okay, but before we talk about that, let's talk about get tuple type. And get tuple type is a template, and it's a variadic template, variable number of arguments. And it's a struct, and it has one element, one member. Using type is an alias, so we're going to say using type equals type name, and we're going to recursively invoke get tuple type. So how does this work? It's not too difficult, but let's start out with our example again, using my tuple base 0 int string. So when I say get tuple type, and I pass in a value here, I'm going to tell it which one of these types I want to get. And then I pass in the list of types. So this is going to be the list of the types in my tuple. And you'll see how that works later when we go down to the get function. But we just build up a get tuple type struct. We instantiate it with 1 in string to get 1. If it was 0, we'd get int. If it's 1, it'd get string, etc. It's, array style indexing. And then we say : type to get the actual type. This is a pattern used in various templates to, basically put a type alias inside of a struct. Okay. So when we do something like this, get tuple type 1 int string : type, that is going to expand out to this, as can be seen here. Using type equals type name, get tuple type, I-1, rest t : type. So this is our expansion. Using type equals type name, get tuple type 0. We're going to pass in 0. Rest t is just going to be string. We peeled off our int as first t. And type. And then, because get tuple type 0 string is just a string, we're going to set type equals string. So it's that simple. By the way, the 0 thing here, how does that work? We need a template specialization for 0. So that we just basically peel off first t and say type equals first t. So it's it's that simple in terms of the recursion. So you can see here my note: struct get tuple type 0 int using type equals int, and it says using template specialization below. So hopefully that is clear how the get tuple type works. You just pass in which type you want as an integer, starting with 0, and a list of types. And the last thing to talk about is get. And this is how we're actually going to get the value. So like in this case, my tuple t1s. How do we get s? How does that work? And it works via casting our tuple, downcasting our tuple to the correct base class. And if we get the correct base class, we basically tell C++, hey, here's this object, downcast it to the correct base class, and we'll call get. And then it will call get on the correct class. So it's very important that this cast work exactly correctly, or things are going to blow up, or whatever, not working. And this is just a template function, taking parameter I and a list of types. And I is going to be an index to tell us which tuple element to get. So in our case, int is the first tuple element of our tuple, 0, and string is the next element of our tuple, so that's going to be 1. It's, array style indexing. Okay. So how does this thing sort of work? It's a template function, so we're going to do type deduction, and the type we're going to deduce is basically going to look like this. We need to deduce this type here. So when I call get with the template parameter 1 on t, my tuple is tuple int string. So this get here is going to deduce that. It's going to deduce that type, tuple int string, reference to tuple int string. And then it's going to static cast the argument and call get on it. So we'll just try to show it here. So I'm going to call get with the template parameter 1 on t. And this is going to expand to a function. C++ is going to create, instantiate this function that's going to look kind of like this. Get tuple int string reference to arg. Return static cast, and I'm reading off of this, this return line, this code in the body of the function. Tuple val 1, that's I. Get tuple types. Again, I'm going to pass in here 1 for I. And I'm going to pass in the list of types, which is rest t. So if you look at here, get tuple rest t, that's the list of tuple types. And it's int string, so get tuple types. I is 1. Here's the list of types, int string. And then I'm going to get the type. I'm going to get the type like I showed you above, how we get tuple type to get the correct type of the tuple. Okay, so that is going to simplify. This is a little like algebra. We're just going to, sort of substitute and stuff. So tuple, get tuple type here, as I showed above, 1 is going to get string. 0 would have got int, 1 is going to get string. So I'm going to replace that. I'm going to simplify this by replacing the get tuple type with I don't think I did that right, but sorry about that. I'm going to replace the get tuple type here with string. So then I have static cast to instantiating tuple val with 1 in string. And that's our base class. That is absolutely our base class that contains our string. So if you followed all this, which might be hard to do, I think this is kind of complicated, but if you followed it, tuple val with I equal 1 and string is the base class that holds the string. So when we static cast our tuple to this type, we are going to get C++. At compile time is going to think, okay, what we really are referencing here is a tuple val1 string. And so when we call get, it's going to get the string. And then when we call get, it just works. And that is kind of how it works. So it's a little hard to follow, but hopefully this has been of some help. Thanks for watching.